Hey there, everyone, and welcome to your first class of the second half of the second semester. And if you can, if you could pause this, there's two things that you should have in front of you, or at least one thing. If you could copy the blank notes from my essay under lesson one, so that we can do this together, that would be great. Otherwise, you should have a notebook so that when we do these practice problems, or so when we do practice some of these, that you actually have them in your notes. One other thing you should know is that once these notes are filled out, I will be posting them on my essay. So the final draft of this will be there, but it's always going to be important that you actually do the problems yourself, practice them yourselves. The only responsibility you have before your next class is to watch this and make sure that you understand it well. You can go to Big Ideas and do the assignment, but the assignment is actually going to be done during our next meet session. So it's not their only assignment, your only homework is to watch, learn, and make sure you understand, so that when we get to the meet session, everything will come clear. Okay, so let's go ahead and get into this. And this is just going to be a review of sections 1 through 4. We've already seen this before. We've taken a quiz on it. But before we move too far ahead in Chapter 7, I just want to make sure that we have a few pieces of vocabulary and some concepts down, so that we'll be able to move through the rest of the chapter without any problems. So anyway, let's go ahead to the first one. It says, let's look at the instructions. It says, write a polynomial in standard form. If you guys remember, standard form meant from high exponent to low exponent. Also, in terms of what the degree of an exponent is, of a degree of a term, you have to add up all the exponents, if you can remember all that. But anyway, identify the degree of the leading coefficient of the polynomial, then classify the polynomial by the number of terms. So here we go with number one. Number one, it's already in standard form because there's only one term. So we don't have to put them in any order. But let's see if we can remember what degree it is. So the degree is going to be 3. And let me get this down. Degree. And the other thing is, and in this case, it's just only one term, so we call this a monomial. And I believe that, and identify the degree and the leading coefficient. Remember that the coefficient is the number that comes right before, usually before a variable. So in this case, the coefficient is -8. All right, so you got the idea? And that is also what they call the lead term. Let's go to the next one. The next one's got 3 terms. We need to put it in standard form. So think about which is going to be the first term in standard form. Will be d squared, and then followed by minus 3d plus 9. Now it's in standard form. The degree of this, the degree of the leading, okay, the coefficient of the leading term. Now, if there's no number here, we assume that there is a 1. So the leading coefficient. So this is just a word that's going to come up later in your math. In this case, it's going to be 1. We don't see that. We usually don't write the 1, but you should know that that's what it is. The name of this polynomial, there's 3 terms. So we call that a trinomial. And again, let's just make sure that we got everything that they asked for. Put it in standard form, the degree, the leading coefficient, and classify it. Okay, very good. And the degree, we didn't do the degree. The degree is going to be second degree, or degree 2. All right, good. Let's look at the next one. Next one's got little fractions on it, but don't get upset about that, because fractions are numbers too. So, but if you look at this number here, this number has the higher degree, and so it needs to go in front. So we're going to rewrite this as -5/6 m to the 6th, and then plus 2/3 m to the fourth. Okay, so what is our leading, okay, what's the leading coefficient in this case? Okay, so the leading coefficient is, once it's in standard form, we look for the number that precedes the variable. That becomes the lead coefficient. So lead coefficient is this very bizarre negative 5.6. Didn't look like I lifted a lot of space to do this. Oops. There's only two terms. Remember that the terms are separated by plus signs or minus signs that are not inside parentheses. So this is actually just two terms. And two terms, like two wheels, are called, we use the word bi, the prefix bi. So in this case, it's going to be a binomial. So two numbers, binomial. How many numbers in this next one? Do you guys see it? There's 1, 2, 3 numbers, right? So this would be a trinomial. I guess I'm doing these all out of order, but it looks like I already made an error here. Okay. Trinomial. And let's go ahead and put it in standard form. So what's the first term? Think about it for a moment before I write it down. Yes, it's going to be the 3z to the fourth. The next term will be the 7.4z squared. And the last one is going to be the negative 1.3z. We do not need to put that plus sign in the front. Don't want to mess anyone up, so I'll erase that. But if you can see again, it got fourth degree, second degree, and first degree. We don't see the number 1 here, but there is a number 1 there. So now it's in order of large degree to low degree, so it's a fourth degree. So, and again, the polynomial is always going to be known by the degree of the lead term. So once we put it in standard form, the lead term tells us what the degree is of the polynomial itself. What else? Lead term, lead coefficient. The coefficient, again, the number before the z. And in this case, that lead coefficient is going to be 3. And we have it's a trinomial, fourth degree, lead term. I think we've got it all. Yeah, that'll do it. So a lot of vocabulary there, nothing huge. Now, the next thing that came up is in section 7.1 was adding polynomials. So this is a polynomial, and this is a polynomial. And to add them, what we need to do is get rid of the parentheses. Now, anytime there's a positive sign, or in this case, there's no plus sign here. We don't really use one. But we can remove the parentheses when there's a plus sign, or I should say that the term is positive. So one way people can look at it too is if there is a 1 there, which we don't usually see, we can distribute the 1, and in a sense, distributing always gets rid of the parentheses. So this just rewrites as 2x squared plus 5. Again, plus sign. Think again. You can distribute a positive 1, which basically just means minus x squared plus 4. So if there's a plus sign, we can just remove the parentheses for all practical purposes. Now we have like terms. 2x squared minus x squared is just going to be x squared. And then we have plus 5 plus 4 for a total of plus 9. Got that? Let's go to this next one. This next one's a subtraction, and this is where we can, if we're not careful, we can make mistakes. There's a positive 1 in front of here and a negative 1 in front of here. So let's go ahead and distribute our positive 1. Well, we get negative 3n squared plus n. Distribute the negative 1, though, and you're going to get minus 2n squared plus 7. Plus 7, right? So be careful there. Now we need to add the like terms up, right? So we got that. Those are n squared, our n terms, and this is our what they call our constant term. So total up, we got looks like minus 5n squareds. N to the 1, we just have 1 plus n, and then plus 7. So always being careful with the minus sign. Look at this, number 7. Again, if you have this sheet printed out or you have a moment and you want to pause and challenge yourself to see if you can do this before I do, your skills will be immeasurably improved. You will be in a really good place. So consider pausing this every once in a while and trying to get ahead of me so that, that you know that you're in a good place with this. Again, we have a positive 1 in the front of this one, a minus 1 in front of that. So distributing 1, we get minus p squared plus 4p. Distribute the negative 1, we get negative p squared plus 3p minus 15. Notice that the negative sign, the negative 1, turns all the signs into their opposites. So let's collect all the p squared terms, and then we'll collect all the p's, and then the constant term. So I'm putting, okay, so minus p squared and another minus p squared for minus 2p squared. Let's go to the next term. I'm putting it in standard form right away, if you notice. 4p and 3p for a total of 7p. And then our constant is minus 15. There's nothing to add to that. So we get this big trinomial here. And again, that minus sign is always is the tricky thing to be careful of. Okay, we got positive 1 in front of this number, positive 1 in front of this number. Makes things easy. Got a squared minus 3ab plus b squared minus a squared plus ab plus b squared. Oh, hang in there, people. We're almost there. But look at these two things. They cancel. That makes things a little nicer. This one here, in terms of standard form, it's kind of tricky because the AB is, that's a second degree. If you guys remember, that's a to the 1, b to the 1, and we add the exponents up to get the degree, right? So really doesn't matter which one we put first. I'm just going to put the b squared first for whatever reason. So I got 2b squareds, and then I have minus 2ab, right? Minus 3 and a plus 1. And that will do it for that one. All right, moving on to our next page. Oops. Forgot how to do that. Go to our next page, and a few more questions that we have. Let me go ahead and move through these quickly because I'm going to assume that you guys know this somewhat. Find the product of these two numbers. Now, there's two ways that we did this, if you recall, and one of them is we're going to do double distribution, right? We're going to distribute the w, then we distribute the 6. So we're going to go w times w plus 7, and then we have the 6 times the w plus 7. Do you see that? W times this, and then 6 times this. Whole thing. All right? W squared plus 7w, and then distribute the 6, you get plus 6w, and 6 times 7 is a positive 42. Now, often we have to add those middle terms up. We get w squared plus 13w plus 42. All right, and I would challenge you now to pause this video for a moment and see if you can't double distribute the number 10. Okay, so here's the answer. If you didn't get this, there's plenty of places to make mistakes, but go ahead and check, make sure you got that answer right. All right. Let's go ahead and pause now, and I'd like you to try this next one. Now, this next one is a special type of multiplication. I think you'll see as soon as you finish it what it is. So please take a moment and double distribute this one. Or if you wish, we can use FOIL. I think some of you have probably already done that already. We'll go ahead and use FOIL. Okay, so if you did this right, you should have ended up with 9z squared minus 25. And if you remember, these are conjugates. Conjugate is a binomial that looks the same, except that there's one has a minus in the middle and one has a plus in the middle. And what happens with conjugates is the outside and the inside of FOIL cancel out. So one of the things that we talked about is when we have conjugates like this, and hopefully, I'm not sure if you can remember that word conjugate, but when we have conjugates like this, then we only have to use the F and L of FOIL. And the F and L of FOIL means the first terms and the last terms. So you multiply the first terms together, you get 9z squared. Multiply the last terms together, you get minus 25. So this again is a special kind of a binomial where the middle term, where the O and the I of FOIL cancel out. 13. I want to do that one with you to make sure that no one makes a mistake, but to write this one out, we have to first write it as t plus 5 times t plus 5. And there's a special pattern to this that we learned once, and I'm not sure if some of you already remember it. But let's go ahead and do FOIL. So you got the first terms is going to be t squared. O, outside terms, t in the 5 is going to be 5t. And now we've multiplied the t by everything. Let's go to the 5. Multiply the 5 times the t, and we get another 5t. And then the 5 times the 5 for positive 25. And these add up together, we get t squared plus 10t plus 25. One of the things that we talked about a while ago is if we have these binomials being squared, notice that the middle term, the first term is the first term squared, t squared. The middle term is you multiply the 5 times the t to get 5t, and then you double it to get the 10t squared, 10t, and then you square the last term. So anyway, I'm not sure if you guys remember that little pattern, but if you do, it's going to help you later on in life. Mostly in math. So let's go to the last 4, guys. Hang in there, hang in there, hang in there. So and this one here we have to solve, and let me remind you how we solve. If we have if we have the term a plus b, this is called the zero property. If a number times another number is equal to 0, then either a can equal 0 or b can equal 0. They call that the zero property. It's I think that we kind of know this, but let's see if we can remember how to apply this. So let's go to this first one, this first term. Now this first problem says solve it. To solve this one, we're going to have to factor it first, and this is actually 7.5. If you guys remember that we look for the common factor, the greatest common factor, and then we're going to factor it out. The number that they both share, or both can be divided by evenly, is 5x. So if you remember, what we'll do is we'll put the 5x on the outside of the parentheses, and then we'll put our 5x squared minus 15x on the inside, remembering that we need to divide each side by 5, both terms by 5x. So remember, we're multiplying by 5x and dividing by the 5x, and that assures us that we haven't changed the value. So finally, we get 5x times 5x goes into 5x squared, x times 5x goes into the minus 15x minus 3 times equals 0. Now take a moment and see if you can remember how I just did that. And now what we do is see if we can remember this. We go 5x equals 0 and x minus 3 equals 0. In this case, we divide both sides by 5, and therefore x will equal 0. And over here we add 3 to both sides, and we get x equals 3. And so those are the solutions that we have for this equation. So if we plug in 0, we get 5 times 0 squared is 0, minus 15 times 0 is 0. 0 minus 0 is 15. You might wonder if the other term's going to work. If 3 works, well, let's look at that. That'll be even more interesting. So you got 5 times 3 squared minus 15 times 3. Oops, sorry about that. What does that equal? Well, 3 squared is 9, times 5 is 45. Minus 15 times 3 is minus 45. 45 minus 45 is 0. Pretty amazing, right? It actually works. Okay, let's do the last ones. Last ones are a lot easier. 8, 16, we just go 8 minus g equals 0, and 8 minus g equals 0. So we're going to get the same answer twice. Subtract 8. You get minus g equals negative 8. Now we need to divide both sides by negative 1. And therefore g equals positive 8. This will also give us 8. So in this case, we used to call that a double root. But the final answer is g equals 8, g equals 8. We'll call that a double root or a repeating root. This next one's going to be maybe a little easier, but in some ways. In this case, we have 3p minus 7 plus 7 equals 0. 3p minus 7 equals 0. And p plus 8 equals 0. So for this one, this one, this one. So it looks like we have we're going to have 3 roots. Minus 7. 3p equals negative 7 divided by 3. P equals negative 7 thirds. Solve the next one. Plus 7. 3p equals 7 divided by 3. P equals 7 thirds. And last one, negative 8. Minus 8 for both sides, and then p equals 8. So those are our 3 answers. And the last one, finish up. Guys, hanging in there, you did a great job. Y minus 8 equals 0. 2y plus 1 equals 0. So divide by negative 3, and again, this just becomes y equals 0. That's one root. Add 8 to both sides. Y equals 8. And then minus 1, and divide by 2. So you get y equals negative 1/2. All right, well, anyway, I'm hoping that most of this came back to you guys. And this is review. Ooh, it looks like we missed a couple questions on the top. Let me just go over how we do number 11 and number 14, just to remind ourselves. This is not something we can do FOIL with because there's a trinomial and a binomial, but we can double distribute it, right? So you're going to y times y squared plus 2y minus 3, and then we're going to distribute the 9, right? So 9 times y squared plus 2y minus 3. Once you distribute those, you're going to collect like terms, and you're good to go. And number 14, you're going to go 2q minus 6 times 2q minus 6. And from here, you can just go ahead and do your FOIL. I'm going to pause for a moment and put the answers down for these two, after which we'll be done with this video. So if you can try to see if you could do number 11 and 14, that would ensure that you know what's going on when you get to the homework. Again, the homework is not something you need to do until we have our next meet session. So if you understand everything that we've done here, then you're in a good place. And I'll see you at the meet session coming up. You take care, everyone, and stay safe, and we'll talk to you soon. Bye.